Hello and welcome to Quick Learning Hub. Today we are going to continue our discussion of reprocessing pattern in Kafka. So we already discussed in our part 1 video the theory and the concept of the same. So if you have not watched the part 1 of this auto repair processing, please do so. So in today's video we are going to discuss the demonstration of our previous discussion. So quickly go through the previous discussion. This is what I'm showing we already discussed. So we are going to have a producer which will produce to the main topic and one consumer consuming that particular event from the topic. Now this consumer is actually going to do the validation, and in case of the validation failure, we are going to store that failed message into the database. Now, as the validation logic is dependent on some static data admin is going to update that static data as a part of that event. The static data update event, the auto repair processing should automatically try and reprocess the previous failed messages that is related to that particular error code. So that is the theory we discussed in the last part. So in today's video, we are going to have the whole architecture implemented in Kafka and Spring Boot. The previous video we were discussing that our incoming message will be very simple without any business logic. We will have only account ID as in our incoming message, and we will have some static data setup already done. So this account ID is already stored in our static data. We will have account ID that will be associated with a risk. In our current setup, we are saying the risk is high for this particular account, and we have two risks, green and red, with the score 0 and 100. So the initial risk will be red risk with the score 100. Validation failed. We are saying the account is a risky account and the associated entity. So that's how we are going to identify which all messages to reprocess. So this we already discussed in the previous video. In today's video, continuing our discussion with the demonstration. Let's go back to the diagram, which will make sense. More than one applications are actually going to interact with the database. So let's make database as a common module. Also some common logic we can see, like the publisher and consumer logic is the common. So let's make Kafka, some of the configuration and other stuff common for the Kafka as well. So here, if you see the common modules, I have databases and Kafka. So let's quickly see what is inside the database. Scenario in our production application, we are never going to use the H2 as where we actually want to store messages for long term. But to keep it simple, and in case you want to run this application locally on your machine, you don't need to have any property change or to run databases. I'm using H2 database, and at the start of the H2 we are already having our schema and data setup. So we need initial static data for risk. This risk will be associated with account and error code. So this is the DDLs table will be available in our in-memory database. And now let's see what are the DMLs. So these are the DMLs which we were seeing, the risk and account and error codes. So this will be initially available as the data for us during startup. Now in the database, we also need to interact with the database. So all the entities, account, error code, and failed message entity, and the risk entities. The repository using JPA repository. Only we have major is here, find by error code in and status. This is we are going to use to determine which all failed messages to reprocess. We'll see, and similarly just the account entity to be mapped to account DTO. That is also I put it in the database module for the common usage, and the database config, nothing, just enabling JPA repository and configuration. In the POM, it will be the dependency will be starter JPA and the H2 database. In the Kafka, we are also going to have the springkafka dependency as the main one, which is required for our use case. Here we have common config for Kafka, which is like which topic we want to listen to, and the container factory configuration and the consumer properties. So this is where we have put it in the common module for Kafka. If you watch my previous videos, this is we discussed multiple times. The main consumer has dependency on database in Kafka. So we have this dependency apart from Spring, pretty standard starter web and other dependencies. This main consumer module we are going to use to publish the event to the topic, and also the listener is in the same module. Ideally, the event generator will not be in the same application. You might receive some external event, but let's say for demo purpose, we have this publisher controller, which is actually going to publish to the main topic. This configuration we have in our application.properties. Here we are specifying that bootstrap server. So this is bootstrap server is running on port 9092 in your local machine. So if you want to run this application, you should have the Kafka bootstrap server running locally, or you can give the configuration of the bootstrap server where it's exactly running. Now discussing controller. So controller is just taking the account DTO, the event published to the main topic. In this particular event will be listened by the main listener. Main listener will listen this particular account data, and account will be just having account ID, only one single attribute. Now the listener listens to this event, consumes it, and maps it back to, because we are publishing it as a string, and now we are mapping it back to the account DTO. We are going to validate it, and the validation logic we already discussed that it is based on the risk. So what we are saying, first we are going to check if this account data exists. If the account data exists, then we are going to validate based on the risk. Now if the account is present, and we are checking if is this account risky. So for our validation, we are saying if the risk score is greater than 50, the account is risky. So in our setup, let's go back to initial account data is with the risk 2, and it's going to be greater than 50. So the initial message, if we are receiving with this account ID, it's going to return true, and this should be listener will actually should save the failed message entity. There is certain additional logic that we will come back. The failed message entity will be inserted in our database. Try and run this much of a code. So now in our application.properties, we are saying the port 8181 for, and the topic where we are going to publish and consume from is the auto repair main topic. Let's run the main consumer application. So our application will start at port 8181, and we should have one endpoint available from the publisher controller, which is at main publish account. So let's wait for this to start. In meantime, let's go to the postman and have our endpoint handy. Now let's say the main publish, it's a post mapping with the account in the request body. So our application is up and running. Let's publish one account ID. So now we say validation failed, account error is this, successfully inserted. Now we know that we have H2 dependencies, and we have enabled the H2 console in our properties. So we should have the H2 console available for us. Let's try and see in the H2 database 8181, and the path we have given in our property is this testdb, and the password we have not specified, so it should be able to log in. Now these are the entities available for us, and initially the failed message should have been empty. Now we have processed one message, so we have a failed message with the status open. So our basic setup works fine. Now what we want to do, let's produce a couple of more messages, but it will be with this. Let's try with a non-existent message. This message is published and we don't have the ID existing, so 79. Let's produce one with the, again, the existing one, 78. We should have 3 messages in our H2 database. 2 with the ID, account ID 78, and 1 with 79. So the failed message ID is 1, 2, 3, and all of them are with status open. Let's move forward. Static data. What we are saying is the messages are failed because the validation failed. But now the validation is failed because the account data, the initial setup of account data was risky. Now as static data admin, they realizes that okay, there are messages failing because of the risky account, but now the account is not risky anymore, and they have cleared this account from being risky to being a non-risky account. Static data admin goes and update the account's risk. So to do that, we have given the account admin an endpoint, which will be the ID of the account and the risk ID. this is a put mapping. So let's say now the current risk of the account is with the risk ID 2. Now we are going to update it the risk ID 1. So that will be now a green risk instead of. And what is exactly happening behind the scene? It's just going to update the risk of the account using the GPA, update account risk. So the account should exist, risk should exist, and it will map the account risk entity that it will get. As a part of successful update of account risk, what we want the another event to be generated and published to the static data update topic. So this is where we are saying if the static data admin successfully updates the data, let's publish another event. This particular event should be consumed by auto repair service, and the auto repair service should fetch all the related failed messages and publish it back to the initial topic. So is successful. What we are doing, we are publishing the entity update event. We are adding header. This header is to specify for in case as of now we don't have other entities, or you want to have it more generic so that you can use the same piece of code in multiple scenarios. So let's say you are saying your static data will not only be account data or only like risk data. Your static data will contains many more tables and many more entities. So you are specifying that okay, this particular update is for account entity, test this particular part of the application. So this is the simple REST endpoint, and this particular endpoint we are saying in our resources, let's quickly check. What we are saying is to run this particular server port 8282, and the topic we are using to publish is static data update topic. The interesting part here is H2 is available in the particular module. What we have done from the main consumer, we are running the H2 and we are exposing the TCP port. So if you see here, we are exposing 9292. Now what we are saying is in the static data REST, if you see the application.properties, the H2 console, we are using the at 9292. This is a hook just to give like not to use external database, but if you have external database and listening to common, you will just specify the URL and you should be fine. Now what we are saying is the same in-memory database should be used for the static data REST service as well. Okay, but if I update it now, the auto repair service is not running as of now. So I'll come back to this static data endpoint. Let's quickly go to the last piece of our puzzle, that is auto repair service. Once the the static data update happens, the message published should be consumed by auto repair service, and the auto repair service should identify and publish all the identify records. So let's go back to the last module that we want to discuss, that is auto repair service. In auto repair service, again we are saying to use the same H2 database, so it will be the similar configuration for H2. And now one is the main topic where we are going to publish, and update topic from where we are actually listening the update event, and the server is running on port 8383, and the Kafka broker is the same in all the applications where we are using Kafka. Now let's go to the logic. What is happening in the listener? We are listening the update topic and we are saying that okay, consume the record and the record value is now null, get the associated failed messages. We already discussed it multiple times, but we are having the entity name passed in the header. We will take this entity name and we will, using this entity name, we will get the error codes. So let's quickly go back to the initial discussion. We are saying we have associated entities and the error code. So we have this particular entity passed in header and we are going to get this error code. And in the failed message entity, we already have the error codes. Let's see here in the failed messages that are failed, we have like for which reason they have failed. So as we know that, okay, this static data is account entity is updated, we will get this error code and we will get all the failed messages. That is how we are going to get the failed messages to republish. Here we are saying get failed messages entities. All the failed messages entities will be available for us, the associated failed message entity. And what we are going to do is we are going to publish those messages. So we will take the messages from the failed entities. So these are the messages that we were initially received and they were failed due to certain validations. So we will take these messages and publish it back to the main topic again, hoping that they might successfully get validated this time because we have certain update on the related static data. Auto repair service will just identify which messages to republish and it will republish. That is the only task. Run it. As I mentioned, we have more logic in the Kafka main listener. Go through that logic as well. What we are saying is, so we are only going to get the messages in the auto repair service which are with the status open and not all the messages. And once the fully processed, we need to update the status to something else. Let's, in our scenario, we're going to update it to close, or based on your applications, or like if you already have those messages somewhere and you have some audits and other stuff, you may want to delete those messages. And but it depends from application to application logic, how they are designing the application. In our scenario, we are going to say, okay, if the message is coming from the auto repair processing, how we are going to identify? Again, we are going to pass certain headers. We are relying on headers. So auto repair, so going to publish certain headers. Okay, it's too far. Let's bring it here, get header. So this is the parameter in the publish method. Our publisher service is actually having like 3 parameters: topic, message, and headers. In the header, what we are saying is we are going to pass a map and we are going to publish it in the producer record headers, add and produce. So here, publishing in headers, we are publishing the failed message ID. So let's say here the failed message IDs are 1, 2, and 3. This particular failed messages ID, the auto repair process will publish in the header. So the main application should check if we are getting the failed message ID in the header, know that this is coming from auto repair service, and it should treat it as a little different. Now let's go back to the main listener. Once the message is validated, we need to, if it's successfully validated, then we don't need to save any failed message entity. For in that scenario, it should be like a success case and we don't need to save the failed message. But let's say the validation failed. Now there are 2 situations. We may be processing a new message which is coming for the first time, or we may be processing a message that is received from the auto repair processing with an existing failed message. So in that scenario, what we are saying is, if the failed message entity, failed message ID in the header, and we get a failed message entity existing, and in that case, if the failed message is failed again, do not save another failed message entity and do not update that existing failed message entity. So we are just printing a log that it failed again. But let's say now we have this failed message entity, but in the next run it is successfully validated. We are just setting the status to close. That is in the case of if we have the already existing failed message and we are reprocessing it. But if we don't have a failed message existing and we don't have a failed message ID in the consumed record header, we'll assume that the process will assume that it's a new message, and if it has failed now for the first time, it will insert a new record. Now let's go back to the demonstration. So now we have all the 3 applications running. We already have our failed messages. Now the idea is the static data admin goes and update the account risk. So for account risk, currently it's 2. Now let's update the account risk to 1. Let's clear the logs first. So only in the main consumer we should have the logs. The validation failed 3 times for the 7978, and there is just in static data there is only Tomcat started. Same with the auto repair application, it's listening. So we have like the consumer running. Let's clear all these logs. Okay, now the idea is we are hitting the endpoint for static data REST application and updating the risk for account ID 1, 2, 3, 4, 5, 6, 7, 8 to risk ID 1, which is green risk. If it's working fine, we should have log here. Okay, so we updated the account risk and added the entity name in the header and published that particular message to the topic static data update topic. Now this particular topic, which application is listening? Auto repair application is listening. So auto repair application should have consumed this record. Okay, now we go to the top of the logs. We have entity name, account entity. For this account entity, we are getting the failed messages, associated failed messages. Now you see we have here 1, 2, and 3 messages. We are adding headers in the message that we are going to publish to the main topic, because we received that, okay, these are the 3 messages that we have to republish to main topic as they are related to this particular account update or the static account data. We publish this 3 messages with value 1, value 2, value 3. Now let's go to the main consumer. The main consumer, it consumes the first message. Now the successful validation of account for the failed message ID 1 has happened. But if you see 679, because the account does not exist, validation has failed again, and there is no update has happened on the particular failed message entity. So this particular failed message should still be open, and these 2 other failed message entities are successfully validated. Now let's see what is the status of our failed message table. So if you see, as expected, this account has been successfully validated and we have closed this status, but this particular account has not been validated even after the account data is updated, because this particular data was not present in the account table. As you might have understood now, that if we have another static data admin API which can insert this particular data with a low risk, and then it should be automatically reprocessed and should be automatically validated. So this is the pattern that we wanted to discuss. Code base available in the Git repo. I'll share the link in the description. Do share your comments. I hope this video helps. See you in the next video.